Hey, what's up everyone? My name is Darwin and today I'll be showing you how to convert your security logs and data to OCSF, the Open Cybersecurity Schema Framework, using Monad. By the end of today's demo, you'll know how to convert your data sources to leverage the OCSF schema using our out-of-the-box transformation templates. Let's jump right in. So we'll start out in our Community Transform repository page where you can see all of our out-of-the-box data transformation templates. Users can contribute transform templates via our GitHub community repository by submitting a PR and having it reviewed by our team following the instructions listed in the README file. Now, jumping back over to the Monad app and opening up one of our OCSF transformation templates. This one is for CrowdStrike vulnerability findings. And here you can see the JQ data mapping script that maps the source data fields to their OCSF equivalents. It also performs any necessary data type conversions and restructures the overall format of the vulnerability findings so that it's more in line with what OCSF recommends. I'd like to draw your attention to our helper function that maps the severity level from CrowdStrike's leveling to OCSF's, and here you can see that critical severity finding is A5, a high is A4, and so on. I'd next like to draw your attention to the event class UID 2002. And so these IDs are what OCSF uses to identify different event and data types. Here you can see that 2002 is a vulnerability finding. And when you jump over to this page, you can see all of the details about the OCSF data model for vulnerability findings. This is where we get our mappings from for the JQ script. Here you could see the severity ID mapping, which correlates directly with the helper function that I showed you previously. The beauty of OCSF is that this data model and other data models are flexible and wide enough that they fit most data sources or vulnerability data sources in this case. So it makes it easier to normalize data across all of your vuln tools, including Wiz, CrowdStrike, OCSF, wherever you're getting that data from. It makes it so much easier to kind of marry it, put it in the same plane and format, which makes it so much easier to work with and much more efficient to build things like SLA and KPI dashboards. If you're doing anything fancy with AI ML, also makes it much easier to do that. And that's one of the reasons why I'm so bullish on OCSF. Not only does it make it easier to work with the data, to build detections, perform investigations, but also it unlocks new use cases because the data is in such a consistent and standardized format. Now, jumping back over to our app, clone this template to our organization, open it up where you could see the before and after of how a data transform would impact and change the nature of a data source output. From this dropdown, we'll select CrowdStrike Vulns, load it up, and here you could see all of the details around sample finding. It's sitting at about 187 lines of JSON. When we apply the OCSF transform, here we can see that this is a .NET remote code execution vuln. We have the CVE ID here, severity level and ID here, and it's now actually 85 lines instead of 187. And the reason for the discrepancy is that we actually get rid of this nested apps evaluation logic field, which has a ton of context around how the vulnerability was discovered, which sensor it used, version, what entity comparisons it made within the Falcon platform. These are all things that are not as relevant to users compared to when you're doing vulnerability remediation and getting very operational with your findings. For that reason, we removed it, which leads to about a 55% reduction in size of all findings coming from this data source, which in turn makes it much more cost effective downstream because you store less data, you ingest less data, but it also makes it much easier to work with because your databases, data lakes, or query engines are not bogged down with as much data. The other thing to highlight here is that on the right hand side you can see that this is structured much more cleanly and it presents the most valuable and important fields up front. That's another cool thing about OCSF. It actually Not only does it standardize fields, but it formats things in a neat manner that make it much more human readable and machine readable for that case. Now what we'll do is save this transformation. We'll jump over to our pipelines. Here I have just a simple pipeline that's sending all of our CrowdStrike vuln findings to an Amazon S3 bucket for long-term retention and compliance. I'll open this up and I'll add a second destination for Amazon Security Lake, and then I will add the OCSF transform that we had just created. I'll tie these nodes together, and one way to validate that our data is actually being converted to OCSF format is by using our view live data feature, where you could see data as it comes through our data pipelines. Here you could see the raw vuln finding, about 187 lines. I know you can't tell here, but this is pretty chunky. And then jumping over to our OCSF transform node, here you could see the class UID. The record size is much smaller, and that's one way that you could validate on the fly how the transformations are occurring and that we're actually converting to OCSF. That's how simple and easy it is to convert to OCSF using Monad's out-of-the-box templates. You can test Monad out for free today by going to our website, monad.com. If you have any questions, feel free to message me directly on LinkedIn, or you can shoot us an email at product@monad.com. Thank you, and I'll see you on the next one.